All right, so now we're going to study the MRS in a different way. We're going to have a different example. What we have here is a following utility function, u, natural log of x1 times x2. And we want to understand what is the marginal rate of substitution at a particular point, at the point 1, 5. What does it mean? Well, here is the graph of the situation. On the x1 axis, I have a particular good called food. On the y-axis, I have another good which is equal to clothes. So this corresponds to x2. And what I've drawn here is an indifference curve, and on that indifference curve, I've identified the point 1, 5, which is this particular bundle. At this particular bundle, that particular bundle lies on this indifference curve, and we want to know what is the slope of this indifference curve at this particular point, and that will tell us the willingness to trade for this particular individual, the willingness to trade clothes for food. Okay. To find the MRS, I want to use this equation here. This is the equation that we found that we proved in class the other day. So we know that the marginal rate of substitution is the ratio of marginal utilities. So we're going to proceed in a number of steps. Step 1 is going to be to identify mu1. Step 2 is going to be to identify mu2. Step 3 is going to be to create the ratio between the two. So let's start with that. Step 1, find mu1. So recall what is mu1. mu1 is the marginal utility with respect to good 1. So it is the derivative of the utility function with respect to good 1. This is a definition that you know of. Okay? And so we're going to then find the derivative of the utility function with respect to good 1, du dx1. So that derivative is what? Well, we need to use the chain rule. So again, when you use the chain rule when you have an outside function, and then inside that outside function there is an inside function. The outside function here is the natural log of something. And of course, the derivative of the natural log of that something is 1 over that something, which is x1 times x2. And then the derivative of the inside function. In this case, we're trying to take the derivative with respect to good 1. The inside function is x1 times x2. We treat x2 as a constant, which means that we write it down. And then we take the derivative of x1, which is just equal to 1. And so these x2 and x2 cancel out. And so as you've already seen multiple times, we get that the derivative is equal to 1 over x1. So this is mu1. Step 2, we find mu2. And so recall that mu2 is the derivative of the utility function with respect to good 2. And again, what is that derivative? Well, it's the derivative of the outside function, 1 over x1 times x2, times the derivative of the inside function with respect to x2, meaning that I treat x1 as constant. And so I write it down. And again, we get 1 over x2, which is our mu2. So now I have mu1 and I have mu2. So step 3, put them together. Okay, when I put them together, I get that in the MRS is mu1, so it's 1 over x1, divided by mu2, which is 1 over x2. I can take this x2 and flip it and bring it upstairs. So if I bring 1 over x2 upstairs, I'm going to flip the x2 with a 1, and I'm going to get x2 equal to x1. So here is the function of the MRS for this particular utility function. Now I'm going to take x1 and x2 from here, and I'm going to then see what the MRS is for that case. Okay. So when we have 1 unit of food and 5 units of clothes, the MRS is going to be equal to 5 divided by 1, which is equal to 5. Okay? The final step here is to interpret this MRS, and this is always very tricky. This is something that always trips me up a little bit. So to have the correct interpretation, we want to think about this situation where we have food on this axis and clothes on this other axis. It's important to see where is clothes and where is food. So recall that another way to think about the MRS is to say that the MRS is delta x2 divided by delta x1. Okay, so this is the change in x2 divided by the change in x1. In this case, x2 is clothes and x1 is food. And we know that this ratio is equal to 5 divided by 1. So let's cross multiply this, and when you cross multiply that, you get that change in clothes is equal to 5 times the change in food. And now you can see the meaning that if I want to change food by any amount, I'm going to multiply that change by 5 to get the number of clothes that I'm willing to give up. So to gain one food, I will be willing to give up what? How much? Change in clothes equals to 5 times the change in food, which is equal to 5. Okay? So that's what it means. It simply means that for each unit of the item food that you want to give up, you have to give up 5 units of the clothes when you start at this particular point. That's it. Thanks for watching.